Hi, everyone. It's 6 o'clock, so I think I'll just get started. Looks like we're missing, might not have everyone, or not sure. Maybe, yeah, it looks like a couple more coming in. But I'll just get started with introduction. Again, it's me again. This week I'll be teaching all about assemblies, which is something we talked about at the end of CAD 1, but we want to go into a little bit more in depth. And also, I know last week we had some homework, and so I'm interested to hear how that went, but we'll get to that a little bit later in the class. But I'll begin with some slides, so let me just start sharing my screen. Here we go. So today we're talking all about assemblies, and what this is doing is that it allows us a way to define how different parts interact with each other. So far what we've done is basically just CAD objects. We took a drawing or an object and we made a computer model in Onshape. And what we did is called the part studio. We just created a whole bunch of parts. But all it does is define the shape of them, but it doesn't define how they interact with each other, which is also important in CAD. And so assemblies put multiple parts together and it defines how they interact. So to go over different assembly types, we have some slides going over the different connections, the different relationships parts can have to each other. And so I did include a link here. So if you look at the slideshow a little bit later, you can click on this link and it should bring you to a shared Onshape document here. But since I'm showing it on the screen now, it's not as important. But if you look at the slideshow on your own time outside of class, you can click this and you'll see everything I'm showing today. But the first kind of connection that we're going to talk about is the fasten mate. And this is like the simplest mate. And as a heads up, I will use the term mate to define, to call like a relationship with these parts. So this is called a fasten mate. The fasten mate is you're basically just fixing objects into place. It's like you're gluing them together. And on the side, the example is like Legos. And so you can see here what I did is I CAD'ed kind of two blocks, one with a circle sticking out of it and another with a hole. And in my assembly, I can add a fasten mate. And I'll just demonstrate that really quickly. We'll go into a little bit more depth later. But it's one of your tools right here, the first one, fasten. And I can just click the knob at the top and then the hole bottom. And you can see they kind of, oh, well, it's a little bit, the orientation was a little bit messed up, but now you can see they've been kind of connected together. And now I can drag it together and you can see both parts are stuck together, right? If I drag one, the other moves, right? If I delete my fasten, you can see when I drag one, the other stays in place. The fasten means that they're just stuck together. So let me undo the delete. I'm not sure if I can, yeah. So now the fastened again, they're connected. So fasten's kind of the simplest mate. Going in order of your toolbar, the next one is going to be the revolute mate. And revolute, it sounds like revolve or rotate, and that's exactly what it does. The revolute mate allows parts to rotate relative to each other. It does not allow them to go in and out though. It's called axial movement. So it can turn, it can spin, but it doesn't move in and out. So an example of this in the real world is like a door handle, right? You might grab the door handle and rotate it, but you don't pull it in and out. So on the document, the next assembly is an example of the revolute. And you can see, let me just fix that. If I can rotate this handle around, right? It's just spinning in place. Notice I can't pull it out. I can't push it in anymore. All it does is rotate. That's what a revolute does. Then we have slider, which allows axial movement, right? So this is kind of the opposite of revolute. Revolute allows you to spin, but not go in and out. A slider allows you to go in and out, right? And an example of this is what's known as a piston cylinder. So if you know like how a car engine works, you have these pistons that go in and out when the engine's running. That would be like a slider mate. So you can see the example that we have here is we kind of have just a block that's cut out. It's like a shell. And then we have the piston that goes there. And you can see I can pull it in and out. I'll fix that part. But this is the slider. You can notice if I move my mouse around, I can't drag it left and right or closer to me or farther away. All I can do is go up and down. Right? That's the only movement that's allowed. Wrapping up a couple more examples. We have the planar, and this is not one that we've talked about before, but what it does is it constrains an object to the surface of another one. So on the side, we have a real world example would be like a hockey puck or like an air hockey puck on a table, or you can think of it as like a magnet on your fridge, right? What it does is it sticks it to the surface, but on that surface, it can go wherever it wants. It can't leave it, it can't rotate, or it can't like peel off, but it can go anywhere on the surface. And that's what a planar mate is. And so you can see in this assembly, I have like a hockey puck on a table, and you can see I can drag it around and it moves, but I can't lift it up. I can't push it in. And notice I added some constraints so it's stuck on this table, right? But on the table, it can go wherever it wants. That's a planar mate. It's stuck to the surface. Finally, the last one we're going to talk in depth is the cylindrical mate. And the cylindrical mate is kind of a combination of the revolute and the slider. So what it does the revolute instead of cylindrical because we don't really want the handle to go off the sliders. So yeah, we don't want that axial movement. Cylindrical allows it to go up and down. So we can see in the assembly, how it works here is there's a block in the middle. Let me just, it's already fixed in place. This gray part can go up and down, right? But it can also spin. It's a little bit hard to control because both of these options are possible. It kind of jitters around, but I'll do my best to show. Yeah. On shape, honestly, it's a little bit funky when it comes to animating these things, but you can see it can both rotate and also move up and down, right? That's a cylindrical. Remember, the revolute only allowed you to spin, right? But I can't pull it up and down. The slider, assembly 3, allows you to go up and down, but not spin. The cylindrical is just the combination of the two. Let me go here. Goes up and down, but also spins.
So you trying to get it?
There are a couple other mates that we're not going to talk as much. So if we look at the assembly, we have the ones that we talked about: fasten, revolute, slider, planar, and cylindrical. There are a lot more tools, but they're not as commonly used. And so we're just going to go over them briefly. There's a pin slot, which does kind of what it sounds like. An example is in this picture right here. You can kind of see that there's slots, the paths for these objects to go through, as well as a pin, which is just like a stick, a cylinder almost. And so this mate just makes sure that the pin stays inside the slot. The ball mate is what's pictured in this one that I've highlighted. It's kind of like a ball and socket joint. It's a sphere inside of like a cup, and it can turn 360 degrees or maybe not exactly 360, but it can turn all the way around in that way. That's kind of how, like in the human body, some of our knees, they're like a ball and socket. That's the ball meat. Um, Parallel just makes sure that two objects are parallel to each other. So you can't like rotate it or, I don't know, do anything funky like that. But it's kind of like a planar mate because it can stay in any parallel surface, but it can also go farther away and closer together. There's tangent mates if you want some part to always be tangent to another one. So if you have like a circle and you have a plane, you can add a tangent mate so that the plane is always tangent to the circle, right? Then there's a couple with like gears involved. So there's gear mate, which allows you to kind of assemble gears together. A rack and pinion is this, where instead of two gears, it's like a gear plus kind of a horizontal, a straight piece with teeth. And as the gear spins, the horizontal part moves back and forth. And then a screw is just like a woodworking screw that turns in and goes in as well. So there's a ton of these different features. We'll see the ones that we talked about. There's the pin slot, there's the ball, parallel, tangent, and then the gear stuff is on the right a little bit. So you can play around with this on your own time. They're not going to be as commonly used as the ones that we talked more about, but they're there if you want to play around with it. The last lecture content I want to go over is the idea of patterns in assemblies. And so can anyone tell me, where have we seen patterns before? Where have we used patterns before in our CADing in Onshape?
For the top of the roof.
Yes, that's great. So in this class, yeah, that's another great example. So in this class, the very first one, we had you create that CAD rook. And to do the top of it, where it like goes up and down, we used a pattern, right? We cut out one section and then just patterned it so we didn't have to do it like 5 times. Another example is when you created the house. To do the windows, you just drew one of them and you cut it out. You didn't have to do like 10 more of them. You just patterned it and said, oh, okay, I want 5 more this way, I want 2 more this way, and you're done. So you're just copy pasting almost. Assemblies also have patterns, right? And the idea is almost exactly the same, right? You do something once, you have multiple copies, you don't want to do each one manually, right? You just want to do a pattern and say, okay, I want 10 more of these, and it does it for you automatically. What's a little bit different about assemblies, the extra feature it has is that when something's patterned, it's not just that it looks the same, but it moves around in the same way. And so I can show this off in my final assembly in this document. Here I did a pattern. So first I added a slider mate. So each of these this pin can slide in and out. Then I did a circular pattern and I did 4 copies of it. So 1 on each side. Notice now when I pull out one pin, all of them move at the same time. That's because that's the pattern at work. Okay, so not only does it copy the slider, but it also makes sure each one is moving at the same time. Right? And this could be useful for if you're designing some sort of like a moon lander, right? A moon lander would have legs that come out on either side so it can sit on the surface of the moon. Each of those legs are probably going to move at the same time. So you can do a pattern so that they move all the same together. So that was a lot of just talking about the concepts, but now I want to move on to like actually doing it, right? So we talked about all these mates, all these assemblies, these relationships, but how do we actually do it? How do we apply it? And so to do that, we have a couple like example models to play around with. So the first one, I know I had some questions when we were gonna revisit this because we didn't really quite finish previously. But now today we're going back to the do nothing machine. So for those of you who are in my CAD 1 class over winter break, if you could pull that up on Onshape, that would be great. If you weren't in that class, or if you don't, I do have this document that I'll put into chat. Or it looks like I can't put it into chat. Miss He, are you there? I think the chat is restricted only to you right now. Okay, well, so if we can't get the chat working, the alternative is actually if you go to Google Classroom, I've already posted the slides for this week on Google Classroom. So if you go to Google Classroom, you can go look at class 3 slides and homework, or the title is a little bit wrong, but you can click the slides. It will bring you here, and then you can click the link on your computer. But this is just a link to my copy of the do nothing machine. It's what we did in the previous class, but it's not assembled yet. All we did was CAD the objects, but we haven't done any of the assembling yet. So we're working from a blank slate. If you open this on your own computer, you probably won't see something like this. But what you can do is make a copy, right? If you're on your own computer and you click on this link, it's probably gonna let you look at it, rotate the view, but not make any changes, or hopefully not. What you wanna do is in these 3 bars right next to Onshape, if you click the 3 bars and then copy workspace, you can give it a new name. So by default, it's just do nothing machine copy. You can hit OK, and then it will open up in a new tab, or actually in the same tab. And then you should be able to edit things around. But for now, I do want to give a couple minutes just so everyone can pull up their version or copy mine. If you're having any troubles getting this open, please let me know now, because we're going to be working with this. Okay. Okay. So if you do have it open, as a reminder, what we're looking at right now, this is called the Part Studio. This is where we did all the CADing, did all the dimensions, made sure all the shape of each object is correct. However, this isn't where we want to go when we're assembling. When we're assembling, we want to go to an assembly. And so you can visit the assembly by looking at the bottom of your screen. You should have a couple tabs. Right now, the Part Studio 1 is highlighted. But if you go and click on Assembly 1, it will bring you to a new page. And actually, the first time you see it, it should be completely empty, like this. It should just be a blank screen, nothing on there. And to get all the objects that you've CADed, what you do is you hit Insert in your toolbar. It's kind of where Extrude would normally be. If you click Insert, you can choose Part Studio 1 and click, and then click on your screen to place it. But notice when I do that, and I pull the parts away a little bit to separate it, notice there's a base and a bar and a slider, but really the do nothing machine has 2 sliders. So what I want to do is click on this part 2 and then put another slider in, because we actually need 4 different parts to assemble. Okay. I guess.
Wait, are we supposed to do this? Because I already, like, is this different than the slider mate and the Revolute mate?
So
No,
I'm
are
going.
we gonna do the slider mate and Revolute mate, or is this like new?
This is still going to be the slider and Revolute mate. Yeah, we just had,
If I had to do that too.
okay. Just as a reminder of what the final version should look like, I have this one, which I did earlier previously. And this will show us the final assembly in action. So I can actually animate one of these. And the reason why it's called a do nothing machine is because it kind of just turns around and it moves. Some parts are moving around, but it doesn't really do anything. It just goes in circles and circles and circles. That's why it's called a do nothing machine. But as a reminder, this is what we want at the end. So you can see that these sliders are moving in the tracks. The handle is turning around and everything is staying put. It's not sliding out. It's not falling apart. It's working nicely, smoothly like this. So if we go back to our unassembled copy, you can see we have a lot more work to do. But anyways, after you insert the parts, you can hit the green check mark to get rid of the menu. And we're just working with these 4 things. So I know Drew already mentioned this, but how about Alex? Can you tell me what type of mates are we going to need to do to assemble this do nothing machine?
The slider mate, I think.
Yeah, so let's do the slider first, right? We want to make these sliders, these gray parts, move in the track, right? Right now I can just drag them around wherever I want, but I want to make sure that they're in the track, not just freely moving around. So the first step when doing assemblies is usually you want to fix a part. You want to just say, this part is going to stay here, everything else moves relative to that. Because right now, all our parts can be dragged around. We don't really want that. We want one thing to be our base. Luckily, in our model, we do have a base right here. So to make sure it can't move around, I just right click and hit fix. And now you can see if I click and drag, it doesn't move around at all. The fix, make sure you're hovering over the part. When you right click, it's kind of in the halfway point of the menu, a little bit above that. Right now it says unfix because it is fixed. So it's just a toggle. So right now it's unfixed. Now I can fix it and it can't move around. And then we want to do the slider mate, as Alex and Drew said. So to do that, we use our toolbar, just like with anything else. And we can find the slider mate kind of the third one down. It looks like a cylinder with 2 lines on either side and an arrow going up. That's showing it's sliding between the lines and moving up and down. That's exactly what we want. So when we do this, how do we add mates? We need mate connectors. And when we hover over the parts, you can see things pop up. You see white dots and then this yellow circle with the blue, green, and red lines sticking out of it. And so when we talked about this last time, I didn't really fully explain what this all meant, but I want to try to do that right now because we're ready to go into a little bit more depth. So if we look at that, what it's telling us is the white dots that are there are like the possible positions I can click on. It's the possible positions where my yellow circle can snap to, right? My yellow circle can't go anywhere. It has to go to one of these white dots, right? And then if I look at my yellow circle, kind of where my mouse is, you'll notice these 3 lines coming out of it. The blue line, the green line, the red line. These represent axes, like X, Y, Z axes. So you can also see these colors, the red, green, blue, on your cube, navigation cube right here. Notice it says X right here, Z there, and then Y there. So red is X, green is Y, blue is Z, right? That's exactly what these lines are telling us. So if I look, the Z axis, the blue line, is sticking straight up, right? Because the Z axis is going up. And then if I look down on it, the X and Y are kind of on that surface. We have X going kind of down and we have Y going kind of to the right. This will be important to remember later, right? But all that you have to know is the white dots are kind of your possible locations, and then those lines represent different axes, X, Y, Z. One annoying part when selecting a mate connector is that there's a lot of possible places it can go to, right? I could place it here, I could place it there, I could place it somewhere on the bottom, I could place it somewhere on the side. You can see there's a ton of white circles, and when I start moving it around, there's a whole bunch of possible locations. To make it easier for you, Onshape has a feature where you can see when my mouse is right here, there's kind of these white dots all around the square and at the center. And then if I move my mouse over here, the white dots move, right? So it knows when my mouse is here, I probably want to click somewhere in this region. When my mouse is over here, I probably want something around here. What I can do is when I'm like this, I can hold control on my shift on my keyboard. And what it does is it makes sure that these white dots no longer move around. Even when I move my mouse to the other square, the white dots don't move anymore. The white dots are fixed, right? Even if I rotate it and I look at the bottom, I can't do anything. I can't do anything on the side. I can't do anything on the other surfaces. The white dots are there. It just helps you make sure you're clicking on the right location. Because if you don't, you notice like it's really easy to start placing it differently. Another note is that you can see right here, this is a different position than what I had before. Because now you can see that the blue line is sticking away from the side of the base. Before, the blue line was sticking straight up. See, now you can see that the green line is sticking straight up and the blue line is going out. So you can see that this right here is different than if I clicked it like this, right? In this position, the blue line is going up. In the other position, the blue line is going to the side. So it's really important to pay attention when you're clicking to make sure you're in the right orientation. If I click right here, it's like I'm clicking on the side. When I'm clicking, if I click here, I'm clicking on the top surface. So it's just important to keep track. So with that, let's just start doing our actual sliders. So this yellow circle essentially is telling us which two positions are going to touch and move relative to each other. So the two positions I want to touch are kind of the bottom of my groove right here. Notice the blue is sticking out, the green is sticking up, and the red is sticking to the side. So I click once, and I've selected that position. You can see when I move my mouse away, it's still kind of there, just a little bit grayed out. So I've defined one point. That's interesting. I want to define the other point. The other one is on my slider. So notice this right here should touch at the bottom of my slider, right about here. Right? And you can see that the colored lines kind of match up. The blue is sticking out, the red is sticking to the side, and the green is sticking up. Right? If I scroll in, it's a little bit easier to see. The blue is sticking out, the green is sticking up, and the red is sticking to the side. So I click again and scroll out. Boom, you can see they've connected together. They've been assembled. Notice now instead of the short blue, red, green, now I have the lines a little bit longer. I have Z, I have X, I have Y. I could click the green check right now and be done. And you can see it will now slide back and forth in the channel. Right here. I can't move it left and right. I can't pull it up and down. It's stuck right there. What was so important about these axes, the X, Y, Z, is if you want to add some sort of constraints or offsets or limits, which are conveniently right here. So let's say, for example, I take a look. This slider can go outside of my base, right? It slides back and forth in the groove, which is what we want, but it also can slide completely out, right? That's because all we said is that this can slide back and forth in this direction, but we never said where it has to stop, right? We never set a limit to the movement. But we can do that by clicking the slider mate on our left side. We can bring it up and we can click limits, right? We can click limits and then it's gonna say Z minimum and Z maximum. So remember, Z is this blue line. It's kind of sticking out. So it's saying, when I start dragging this around, the distance between, right here, the Z value is 0.5, right? If I drag it here, you can see the Z value is negative 0.93. I drag it here and the Z value is 2.6. So I can set a limit on this value. I can say, I don't remember the dimensions exactly, but this is probably about 3 inches or 3.5. So I can say the maximum right here is 3.5 inches. And I can say the minimum value is going to be 0 inches. Right. And so once I do that, it says 0 and 3.5. I can hit the green check mark again. And now I can see my slider. It still moves in the groove, but now it doesn't leave, right? It stops right there. And then it stops on this end as well, right? I've set limits. All I said, it can be 0 to 3.5. It can't be negative. It can't be greater than 3.5. It's stuck there, right? But actually for this do nothing machine, if we have this limit set, it's actually going to cause problems later on. So we want to uncheck it. So if you're following along and you added limits to yours as well, you want to get rid of them. And you can do that just by unchecking. So I don't want limits anymore. That's because the way we CAD'ed this design, the slider actually has to go slightly past the base. So if we set a limit, then it's not going to work anymore. It will turn a little bit, but then get stuck. But we did one slider. Now we can do the other one. So what we do is now I click the slider again, slider mate. I select kind of the same 2 points. Notice it's a little bit weird because now the green is sticking down instead of sticking up, but the blue is still going out and the red is still going to the side. So I can just click there and I can go to my slider and I can click the same thing. I click again and it's behaving a little bit weirdly, but what I can do is I just flip the primary axis. I can rotate it around a little bit. It should be good. So that's one way to do it. It was also fine how it was, honestly, before. So let me just get rid of this meat. Let me delete it. Let me just do it again to show. Slider. I select my first point, which is right here. I select my second point, which is right here, and boom, they stick together. I can hit my green, and you can see that this one also slides back and forth, just as we want it. Then we're almost done. We have these sliders going back and forth, but now we need to attach this handle, right? This handle is still floating around. It's doing nothing. So I want someone else. How about Jacob? What mate do we need to add to connect this handle to the sliders, right? We want this handle to stick onto them, right? But we also want it to turn around. So what kind of mate do we want to use here? Oh, Yes, Miss He. The chat I think is restricted to only me and you. So if you could set it to everyone, that would be helpful, I think. Okay. But in the meantime, I'll ask someone else. How about Selena? What do you think we want to add to connect the sliders to the handle?
A revolute maybe.
Yep, exactly. We could do a cylindrical because they're very similar, but in this case, we don't want the handle to go up and down on the pin, so we want to use a revolute. So we can hit revolute. We can select our points just like before. So where do we want the things to connect? Well, the center of our pin on the slider, as well as the center of our hole right here. So I can do it like that, for example. You can see it's kind of intersecting right now. The handle is kind of inside the slider. That's because of how Onshape decided to place things. We can fix that by just kind of turning it around. We have these buttons right here. This, we can flip the primary axis, which is what we want, or we can flip the secondary axis, which is not what we want. Honestly, it's really hard to get an idea of which one's the primary and which one's the secondary. But you could just play around with these buttons until it places it where you want it to. In this case, the primary axis is the axis of your pin. So you can see that this pin is going up and down. So the primary axis is the Z axis, and flipping it just flips it on the Z axis, which is what we want. Well, we can hit check, and now you can see that this handle rotates around, but also has the sliders attached to it. And then we can just add one more revolute in the same way to connect this pin with this bar. Right, so let me do that. We want this point, the center of our pin, with the center of our handle. But I want it at the bottom of the handle. So it's kind of a pain to get it selected properly. But if we can do it there, hopefully everything solves. We can hit the green check. And now it has also attached these two together. And if we've done everything properly, it solves this sketch. It makes sure everything follows the rules that we told it to. And now we can just turn it around. It's a little bit jumpy, but we can turn this handle around and you can see that it does exactly what we want it to. The sliders stay inside their grooves and the handle turns around on the pins. So it just goes back and forth and back and forth and back and forth. Notice what we can do to get the cool animation is you can actually animate any of your mates. So for example, I want to animate this motion, I just want to animate one of my revolute mates. I just want it to go automatically without me dragging things around. And so what I can do is on my side where it says the mates, I can just click on one of them and right click. And then animate is kind of at the bottom. So it's delete, add comment, then animate right there. If I click animate, it brings up a menu. Basically, it just asks me some parameters. If I just go with the default ones, it's pretty good. You can see I'm not moving my mouse around and it's automatically turning. But in this case, to make it look a little bit better, some settings I can choose is loop instead of reciprocate. And then I can decrease the steps to make it go faster. So I can do that. So it loops forever, just goes in circles. So at this point, I want to take a pause because I know I took the screen sharing for a long time. But I want to know if people had issues following along or are confused or just want to show off their assembly. So I'm going to stop sharing and I just want to ask if anyone wants help with everything that we just talked about. Let me stop sharing. If you had trouble following along, please speak up now, and you can also take the screen sharing as well, just directly.
I need help.
Okay, Ryan, can you share your screen so I can see your Onshape? Cool. So, okay.
So when I try to spin it, it does this.
Okay, so let me look at what happened. Okay, so some of these are saying that they're red, which means they're not, yeah. So first delete that because I don't think that should be necessary. So if you just click and hit delete on your keyboard, or maybe right click delete. Or, okay, what is that from? So did you do the revolutes before the sliders?
No.
Okay. So yeah, the ordering does matter a little bit, but it looks like it's having some problems with your slider mates, and that's probably what's causing the issue. So if we, do you see the ones that are highlighted in red?
Yeah.
I want you to delete them. So the slider 2, the slider 3, and the revolute 3.
It's not letting me delete them.
So if you right click on slider 2, does it bring up any menus?
I'm on a Mac, so it doesn't, I can't do.
Does delete on your keyboard not get rid of it as well?
No, it doesn't.
If you just hit X right here, would okay. It's a little bit tricky because I'm not sure which ones are. If you click on slider 3, I think that's okay. So you'd have to redo the slider for that other pin. So you've selected one of the points, but you need to select 2 of them. So try redoing that one right now. So you can click that one, yep. And then at the bottom, yep. Hit the green check. Hopefully this should be working now. Yep.
Yeah.
So that was the one slider that was causing problems. Yep. Does anyone else have any problems or questions that I can help with right now? If not, I want to talk a little bit about the homework that we had you do last week. So last week, Eugene taught you about how to read drawings and how to CAD from a drawing. And for homework, we gave you 2 parts to CAD and just create on shape. So I just want to know, how do you guys feel about that? Did you have trouble, or were you able to CAD everything? Okay, so Peyton, did you have a question?
Yeah, when I tried assembling it, it didn't work out for some reason. Like the beam in the middle, like it was like like right before my hole in my clevis. So
Okay, so we will actually talk about the assembly right now. It was a good question. What might be the issue is that for assembly, what types of mates did you use?
I used revolve mates.
So what we actually have to do is use a combination of revolute as well as cylindrical. The reason for that is, let me share my screen again. This is the assembly that we're going to have you do. And notice that the shaft of the clevis kind of sticks out a little bit. That's because just how the geometry works out, it has to stick out just this tiny bit. And so when you do a revolute mate, it tries to make it so that it's not sticking out. One side not stick out, and you make the other side not stick out, then it's just impossible to solve. It's just impossible to do geometrically. And so you probably have some red mates. That's the issue there. So for these, we're not going to do revolute, but we're going to do cylindrical. Yep. The ones here, though, these can be revolute. These just spin, and they're perfectly flat at the top. But before we go too far into the assembly, I do want to make sure, does everyone have the different parts completed? So I believe the clevis you all did in class right here, but for homework, you had to CAD the bearing cross, which looked like this, and the stand, which looked something like this. So just right now, did anyone have any trouble completing this?
Yeah, I couldn't do
Because,
it.
okay, cool. No problem. Did you have trouble with the bearing cross or the stand, or both?
Both.
Okay. So I'll try to go over the solution briefly. What we had you do is we gave you these drawings. So let's look at the bearing cross because that's a little bit easier to do. So we gave you this drawing and we wanted you to CAD it. And so this is where we're starting to move away from, I'm just telling you, here's how to do it and you follow along. We want you to try to figure out how to do this yourself on your own. Because when this class is over, we want you to have the skills to design things on your own and not just in a class with us telling you. So we look at this, we kind of try to think, what are the steps that we're gonna need to do? So you can see the bearing cross is kind of made of two cylinders, right? So you might think, let's create a sketch that's a circle and we're gonna extrude it to form a cylinder. And we're gonna do this twice to make two cylinders. And so we can do that by, let me just create a new part studio and a new drawing. So the bearing cross, what you wanted to do is create a sketch with, let me just make sure I'm looking the correct way. You want to make a circle. The dimensions were in the picture, so you can see that the circle is 0.25 in diameter. And so what you would do is dimension this to 0.25. It's pretty thin. And now you can just extrude this to form one of the cylinders. So the trick with this bearing cross, what made it a little bit difficult is that if you just do an extrude like this, it will be really hard to do the other cylinder, right? Because you don't have a surface to create a sketch on, right? You don't have a flat surface that you can click and make a plane. You could do it on the front plane, I guess, but then you'd have to make sure that the circle is at the right position. So the easier way to do this bearing cross is to make sure everything's centered at the origin. Oftentimes the origin is the center for everything. So in this case, what we can do is we want this to be 1.5 inches tall. So one way we could do it is we extrude 1.5 divided by 2 up. And then we extrude again 1.5 downwards, or 1.5 divided by 2 downwards. And together that makes one of the cylinders. And then we just create another sketch on the right plane. We create another circle centered at the origin. And this is also 0.25 that you can find from the drawing. And then we just do the same process. We extrude or I don't want to create a sketch. We extrude the circle. We can extrude it one way, 1.5 divided by 2, and we can extrude it the other way. 1.5 divided by 2. And this way you get the bearing cross. It's just two cylinders that intersect in the middle. Another way to do this is instead of these two extrudes, there's actually something called a symmetric extrude. And so normally we've just done blind, which is saying extrude this amount, 5 inches, 2 inches, 50 inches. What we can do is symmetric. And it's basically saying extrude on both sides. So you can say, I want to be symmetric so that the circle is the center and I go out on either side. And then I want the total length to be 1.5, which is exactly what we want. And in this way, we get the bearing cross. The stand was a little bit more complicated because of how the holes were positioned. But the way we wanted you to tackle this is to create this profile, this top one with all the dimensions on a flat sketch. So you just do it how it's dimensioned. Like this horizontal is 7 inches. The length of this inner side is 3 inches. And then it's just 0.5 inches, half an inch of distance between the inner and the outer. And then the angle you have to define is 1.105. And then you put 2 circles on either side. So what that should look like is, let me go to the stand. So just to go over it briefly, we can take a look at the sketch. So this is what the sketch might look like on, if you did it yourself. Let me rotate it so it looks kind of nice. So you can see it has all the dimensions that we said. It's 7 inches on the inner dimension. We have angles of 105. And the way we CAD'd this is we actually used a tool called offset. So we just said the offset is 0.5. And then we said each side is 3 inches on the inner dimension. And then you can extrude this to form the base without the holes, just like this. And then you create 2 sketches on the side to extrude out a hole on either side. You just draw a sketch, you position it to how the drawing tells you it. So here, the hole has to be centered along this edge. So it's perfectly in the middle. And then the distance from the center of the hole to the top is 1.5. So this homework was just testing, can you read the drawing? Can you figure out how to CAD on yourself? So we know we kind of just threw you into it. We kind of just asked you to do this, try to figure out on your own. So I understand if it was a little bit difficult, but we're gonna have kind of a similar homework this week, but it will be a little bit easier, I think. Definitely not as complicated as this drawing. But hopefully you can get some practice. But if you do have trouble, and this is for anyone, if you have trouble doing the homework during the week, we really encourage you to reach out to me or Eugene. Our emails are listed at the beginning of the slide. Because for these homework assignments, these are parts that we're going to be using in class later on. So if we really want to make sure everyone has them completed. We don't mind, we're happy to help if you get stuck. We just want to make sure everyone has the parts so we can move on smoothly. But for the U-joint, let's look back at here at the assembly. I've kind of given away what kind of mates that you want to use. We have 2 cylindrical mates and 2 revolute mates. And so you can see, let me look at 1 cylindrical. What I did is I want to make sure that this post, this stick on my clevis is cylindrical to my hole. So I can actually get rid of these mates if I wanted to. And I'll just demonstrate it on my screen really quickly. And for homework as well, I want you guys to assemble this on your own. But I'll just demonstrate it really quickly. Don't worry about following along because they'll be for homework. But cylindrical mate, this is the way I do it is exactly the same way I do revolutes. I just click one circle right here, and then I click another circle right here. Oh, I didn't click the first one, so let me do that again. And so now you can see it can slide in and out, but it can also turn around. That's a cylindrical. I want to do the same on the other side. So I click there, and I click in my hole, hit check, and you can see this other side also goes in and out and it turns around. Right? Then I have to assemble this middle portion. I have to connect this up with these. And so that's going to be some revolutes, right? Revolute, again, I have the kind of the pin and I have the hole it slides into. So right here. Hit check. You can see now it's kind of assembled properly, and hopefully, let me just fix this one. You can see that this one now turns according to my revolute mate. And then finally, I just need to add one more revolute mate on the same way. So click there, and it looks a little bit funky, but when I click solve, you can see it positions everything properly so that all of the mates that I've done so far are followed. They're kind of like rules that you have to follow. When I click solve, it just makes sure that everything can be followed. If you click solve and you get a lot of red mates, a lot of red text, that either means that means that you did something that's impossible to onshape. You said assemble it in a way that is just not physically possible in the real world. And you want to just, in that case, you just want to recheck your mates. Sometimes you have to delete them and redo them. It's Onshape's a little bit funky in that way. But more often than not, it's usually something that's just geometrically impossible to do. But in this case, since we CAD'd everything properly, it is fine. And we can solve it and just hit the green check. And now we have everything assembled again. You can see I can animate one of my cylindricals. And if I animate it, you can see everything spins just like how it was before. The cool thing about the U-joint is, Eugene might have mentioned this before, the U-joint is used to transfer rotational energy from one axis to another. So you can see that the two sticks, the two shafts, these are not on the same line. They're angled. However, you can turn one side and then the other side also turns, right? This wouldn't be possible if you just connected them together, right? It would be really funky.
I have a question. I need help. I did my cross thingy for homework, but I didn't know how to do the other one.
Okay, so for that, I will release this Onshape document that we're working with. I'll post it to Google Classroom, like an Onshape sharing link that you can take a look at. Unfortunately, we're at the end of class right now, so I would encourage you to take a look at that and email me or Eugene if you have questions. We might also have time at the start of next class to talk about it a little bit more in depth.
Okay.
Yeah, but before class ends, I do want to talk about the homework for next week. So on the slides, it has instructions. It's just another CADing from a drawing. So we have, well, first of all, I want you to complete the U-joint assembly. So we had you CAD the clevis, the bearing cross, and the stand last week. And for this week, we want you to assemble it together. So I kind of showed it really quickly just to give you an idea of what you need to do. But I want you to spend time on your own to make sure you really understand how this whole process works. Clicking on the mate connectors, making sure it all assembles properly. Then when you complete that, it should hopefully not take too long. The next one is we have another drawing for you to take a look at and CAD. And so we have a small version here, but you can see a bigger version on Google Classroom already. So this is the base. This should be, there's a lot of dimensions here, but this should actually be easier than the stand from last week. You can see it's basically just a square with some holes cut into it. The only thing to pay attention to is where these holes are positioned. Make sure you read the dimensions. And also you can see that the holes aren't just a straight hole all the way through. You kind of have a wider part, a bigger hole here, and then you have a smaller hole here. This is called a counter bore. This is for if you were to actually make this in real life. The screw head kind of sticks out a little bit. So if you cut the hole a little bit larger, the screw can sit inside the piece and not stick out because we want this side to be completely flat. But this is just the homework for this week along with the assembly. You can find this picture on the Google Classroom. And we want you to complete this by next week. I know I went over just a minute, so I don't want to hold you any longer than I already have. If you have any questions, I will be sticking around to answer them. But if